Now we have our first talk, Peter Hutterer from Red Hat. He's not talking about input, which he usually does, but about X integration testing, X server integration testing. So go ahead, Peter.
Yeah, good morning, everyone. My name is Peter Hutterer. I work for Red Hat in sunny Brisbane. And instead of input, as Egbert said, for the first time I'm going to talk about something else. I've been working on X-server integration testing for about a month and a half, or 2 months now. And I'm just going to give you a quick overview. The main purpose of this talk isn't me to present everything. It's supposed to be at least half of the time is going to be a discussion, because I need your input to tell me where we're going to put this, or where we're going to push this towards. So the talk is going to be quite fast, but I'm not going to actually show that much anyway. So first of all, the premise of the whole thing is testing is hard and manual testing is incredibly painful. Most of the bugs I see these days are things like, if I have this specific device, I click that button, move 50 pixels to the left, and then click that other button, something crashes, burns, or just generally goes to pieces. Doing all these tests one by one takes forever, and it's quite common for a lot of my bugs to just come back. Sometimes in the way that we fix a bug, 3 releases later, we realize that 2 months ago that bug has come back and no one noticed, because no one has done that exactly 50 pixel movement, for example. So we get a lot of zombie bugs. In at least one case of a driver, what we had is we had to change the default for a bug, and then 3 releases later we had to change it back because of the same bug. So essentially, once we broke all configurations for the people in the first version, then we broke all the configurations for the people in the second version, and generally everybody's unhappy, including me, because I got all the hate mail. So what we do need to do is a automated test suite. I just want to be notified when something breaks whenever I fix anything. That's the premise of the whole thing. We have the X test suite, XTS. XTS is not going to be that automated test suite. I don't know if anyone has worked with it. There's a couple of reasons why it's not it. First of all, one of the big pain points, it's published under the artistic license, which means in every file you modify, you have to write up the top what you modified in that file. I don't know who came up with that license. It's not the ideal one. It's crafty code. We did manage to build it in AutoTools a couple of years ago in the 1.8 timeframe, but the code itself is painful, mainly because it's written in a language that's not quite C, but still looks like C and is then compiled to C. So there's all sorts of macros and so on and so forth. It's virtually unreadable for the uninitiated. And even though the tests, once they're written in, once they're actually in C, are a bit better to read, it's still very painful. And as I said, it was written about 15 years ago or something, so you can see it in the code. There's no real automated log parsing. So yes, you get all these logs, but you still have to go through it manually to actually figure out what failed and what didn't. Which also means why it needs the auditing. The one thing XTS has going for it, it's got around about 1,000, 1,100 test cases. I didn't actually count them, I just ran a git grep, so that number might be off by a few. What we do need is a simple combined tests for server and driver. So you say I have this driver version of that server version, for example, whatever Fedora ships at the moment, and I just want to run the tests against it to know which bugs have come back, which bugs didn't. Premise here again is that writing test cases must be simple. One of the things I'm going to push for as soon as we know where to go with all this is writing test cases should be required. Whenever you fix a bug, we should have a test case to say, look, this reproduces it, it doesn't reproduce it once the fix is in. So at least we know when that particular bug comes back in some form. Parsing output logs must be simple because no one is going to look through it manually anyway. And executing tests must be reliable and predictable, which is one of the big issues with XTS. Executing a single test is a pain, because you have to set up environment variables and so on and so forth. We've abstracted a lot of that as well, but it's still just executing a single test is very painful. So the thing I've been working on is the Xorg integration test suite, because I'm so creative with names. It's based on Xorg G-test, which has been started by Thomas Voss and Chase Douglas from Canonical. They originally wrote it to do some Unity testing for the touch stack in Unity. It's already on the X-server Git repositories, Xorg Git repositories. I'll just give you a quick overview. It currently just consists of, okay, doesn't render properly. It currently consists of 5 classes. Main class here is the X-server class, which essentially just starts up an X-server with a couple of options, parameters, and so on and so forth, and then terminates it at the end of the test. Test is the parent class for the actual test. It just sets up the display connection and so on and so forth. And there's a couple of other ones. Device, particularly important for a lot of my tests, where you can actually emulate a input device that plays a specific sequence of events. So Xorg G-Test is a C++ framework based on Google Test. I don't know who of you have heard of Google Test. I think Mesa is using it, or at least has it in its repositories. Google Test is a C++ framework, and essentially a huge collection of various macros that assert certain things. So you have assert equal, assert not equal, assert true, assert false, and so on and so forth. And it's also got a couple of macros, I'll show some off, that expand test cases into actually usable code. It provides several ways to execute a test. So you can just execute the test, you can provide parameters into a test, and so on and so forth. And one of the more important things as well is it's either text output on the TTY or XML-based logging. So you can pump that XML into integration systems. Ubuntu, for example, does that with the system called Jenkins. I don't know if you know Jenkins. It's a spawn of Hudson, if you ever heard of Hudson. I'll just give you a couple of example test cases just so you know what I'm talking about here. This, for example, is a test for testing the IPTEC driver, one of the most popular drivers we have at the moment, which I think hasn't been tested for a couple of years before we wrote that test. Very basic principle. We have a server object up there. We write a configuration with a basic input device section and a couple of other defaults. We start the server up here. We open a display connection, query the version. We know we need this and this many devices. We check, depending on the version, the device number changes. We check that the devices we find is actually the same thing. Then we remove the configuration file again. We remove the log file. We terminate the server. So ideally, if the test just succeeds, there's nothing left in the file system. The way this particular test is hooked up, that if the test fails, all the log file and the configuration is still left in the temp directory it was written to. Yes? For this particular driver, no, because it'll still start up even if there's no physical device present. There is a ELO graphics test that is similar. We actually have a little class that emulates a ELO graphics serial device, pumping into a pipe, reading that from the driver, and so on and so forth. So that's a very basic test. The test macro up there is what Google Test requires. That just means expand this into a function that is called. One of the more interesting ones maybe up there is, or the other interesting ones anyway, the test P for a legacy driver. So this bit tests all the legacy drivers listed in the last line, if you can see this. I'll just move that up. So this list of drivers is being tested by those 50 lines of code, or 30 lines of code, whatever it is, which does the same thing. It gets the parameter, which is the driver name. It writes an email, xorg.conf, starts up the server, checks if the module has been loaded, and then exits again. Main thing for this is to check if the ABI is broken, for example. So if you haven't built the driver with the right ABI, this test will complain. It still doesn't expect the driver to actually load because most of the drivers don't load. Last test I'm going to show you is Synaptics test. It's a bit more interesting. It actually uses a class. I hope you can see that here. So you've got the class Synaptics driver test. We set up a certain device up here, which is a uInput device. We set up configuration and log. We write out the configuration file. The rest is abstracted already by various functions. And then if we go down, where is that test? For example, the tapping test here. Test F simply means that it's using a class in the background, so it's using that class I just showed you. So we set the clickpad property, we select for some input, we play a sequence of events which is recorded from a physical tap event, sync the display, we check that we got a button left press, we check that we got a button release press, and then we finish. Same thing you can do is if you set the soft buttons, you can check for button right press, and so on and so forth. So as you can see, it's reasonably simple to actually write cases, test cases. Right, so this is the part where you can kick in now. So the few questions that are remaining here mainly is Google Test the right framework? Do we want to commit to it? It's got a couple of pain points. For example, you can't build Google Test as a library and link to it because it's using so many macros that the C++, one of the C++, the one definition requirement kicks in, that you essentially always have to build Google Test from source into your binary. So that's one of the main pain points because AutoTools makes that as hard as possible as well. Scalability to accommodate future tests. Right now, a lot of the tests I have configure some driver option, then start the server, kill the server, which means that if you have, say, 50 tests, starting the server, killing the server takes about 5 seconds in total, even if the test itself is only a microsecond. So with 50 tests, that just expands. So running the whole test case already takes about 20 minutes or something. I don't know. It just does. I don't know. I haven't actually looked at that yet. But starting the X server, even with a dummy driver, connecting to it, running the test, bringing it down, and terminating the X server takes a while. Yep, we can do that. All these tests, by the way, use the dummy driver at the moment, the input ones, so they don't actually write to the graphics card, so they can be run in the background. Yeah, so that's one of the things. It just takes time. But even if we manage to get the X server down to, say, 2 milliseconds, starting an X server for every test is still going to explode rather than just starting one X server, running 500 tests against it, which we can do with XORG G-test as well. There's a class for that. One of the other things for scalability is how do we actually name tests. XTS, for example, names all the tests according to the XLib chapters or the X protocol extensions. We need something similar here. So right now, all the Synaptics tests have a Synaptics prefix, but already it's getting quite messy with the names. Testing version combinations is one of my biggest worries because I already have a couple of ifdefs in there. So if you test a Git server, if you test a 1.11 server, if you test a server against RHEL 6, you have to have ifdefs because that server might reply with true here, but it might reply with false there because of a feature we added. So we kind of need to keep this in check that we can actually test the right versions against each other. And to be honest, that alone is one of my major driving points that I'm tempted to merge all the input drivers into the server to avoid that. Documentation of test cases. Somehow we need to have a unified documentation about that someone reading a test immediately knows what this test is about, if it fails, why it could fail, and so on and so forth. And controlled execution of tests. Just a side bit, Google Test makes that quite simple. You can apply substring filters, so you can, for example, say run all the tests that have the substring this and this, or the regex this and this in the test name. And finally, integration systems. Ideally, we should integrate that into a Tinderbox or something like that to shout at us if something breaks. All right, any comments? Any suggestions? Any ideas? Not all at once. Just to give you an idea of how they actually execute the tests right now, if you look at this, you can see a couple of binaries. Those are the various tests. How you combine them into binaries doesn't really matter. And then you just run the, say, Synaptics driver tests, and it just keeps running like this. So this actually creates a device in the background. It creates an EXO with a dummy driver, and it just keeps running.
So Peter, if you get any of these tests put together, I'll definitely run them before I push any bits to the repository. The longer the tests take, the less often I'll run them, of course. So I think one of the things we do need to work on is making sure that we can. I actually like the fact that the tests start and stop the X server. I think that gives you the cleanest environment and the most reproducible system. So I think one of the things we need to do is just make sure that the X server does start in, like, 10 or 20 milliseconds. There's really no reason it shouldn't. And at that point, I can run the tests at every time I push. If it takes less than 5 minutes, it's not a big deal if they can run in the background or run on another machine.
So one of the things that definitely delay the whole thing is parts in XORG G-test and in the test as well. We do have a couple of wait loops in there that we need. For example, if you test hot plugging, you create the device, that takes a while, and then you just need to wait for the device to appear, and that might actually take half a second.
Okay.
So all that, and if you do that with every test, it just adds up.
Right. Well, and I think what we're going to end up doing is going through and finding out where the slow parts are in the tests and commit to making them better, because that's good for everybody, right?
Yeah.
If your device hot plugs in less time, then we're going to be happy hot plugging more often. So I think this is actually it's a fine thing if we are limited by the speed of the system, because it's going to encourage us to improve the speed of the system.
Yeah. Yep. So just quick, if you can see that down there, that's one test failing as well because we get one too many scroll events. We only expected 10, but it's actually 11. I need to fix up that test. I think that's actually a broken test. But that's how it looks like when it actually fails.
I have my traditional question about OS other than Linux. for example, the input test that you show rely on the UDEV auto configuration of the
Correct.
server. So at least I think it would be nice to have a way to mark tests that are specific to a given system, so that we can run those tests on other systems without having a lot of failure that are just caused because the tests were written in a way that they only work on Linux.
So right now, I think only 1 or 2 tests actually use hot plugging. Everything else uses static XOR conf because it's just faster to write it out. The one thing that will kill every other system is that the device emulation works on U-input, which only exists on Linux at this point.
Well, for example, for OpenBSD, I can probably come up with a solution because we also have a way to generate fake events into our input driver in the kernel. So it's possible to do the same on OpenBSD, just have to implement it and make gtest be aware of that.
Yeah, you can abstract. The one thing I do want to avoid is having several event recordings that aren't cross-platform. Right now, the event recorded can be converted in whatever OpenBSD uses. I just want to avoid to have 17 different files that are all at tap, just recorded on different operating systems. So we need to wrap that accordingly. But other than that, it's all abstracted by the driver anyway. So how you pump it through the kernel is,
Okay.
The other thing is there's probably plenty of tests that we can still run without actually needing input devices. For example, output-wise, there's one test at the moment that tries to load every output driver and checks for AVI issues. There could be other ones where you load that driver with that config, you make sure that XR and R actually responds with the right values and so on and so forth.
So would it be useful for us to actually get a list of, create some testing environment, actually have necessary input devices to do testing? Can we get a list of what input devices I would need to run the tests?
At least for the input devices, they're all already emulated.
Okay.
I've got a massive repository with virtually every input device I've come across in the last half a year or something. So I've got all the Wacom devices and emulations and so on and so forth. The one thing we do need on a bug-to-bug basis is the specific event sequence that triggers it.
Okay,
But,
so other than that, we don't
usually-
need any physical devices at all.
We don't. For input, you don't need any physical devices,
Cool.
unless you have a serial device. But even that you can emulate. If
Okay.
you,
Well, let me know if you want to integrate the drivers into the server.
any what? Sorry.
If you want to integrate the drivers into the server
I'm
sometime.
tempted. So.
I told you you would be.
Yeah.
Just wanted to make a couple comments on XTS because I think we're among the people who used it most recently to actually do anything interesting. When we brought up XCB, we were obviously running XTS against that to see what, the xlib XCB to see whether we'd broken anything. There are a lot of tests there. Not all of them are terribly useful. I think the ones that are could be pretty easily ported to something like Google Test without too much grief. I mean, the problem is just that there's so many of them, right? But I mean, a reasonable group of people could do it pretty fast, I think. One thing...
There is a high chance that you can probably run Coquinel, how you pronounce that, to convert the C file from the XTS into a Google Test compatible test frames.
So it wouldn't have to be done manually. That'd be even nicer, or at least not entirely
manually. The problem with XTS is it seems to abstract half of XLib as well.
Yeah.
So.
Well, the other problem with XTS that I wanted to point out is that we found a lot of broken tests, and I suspect there are broken tests we didn't find. The people who wrote it clearly wrote it very quickly and without super deep understanding of what they were doing, and it's really reflected in those tests. I really think we need something like what it is. I mean, the XCB work convinced me that it's really important to check that we're doing the protocol right, as well as drivers and input and whatever.
One of the things that XTS exclusively tests is protocol, though. It doesn't test any server behaviors other than what's defined in the protocol.
Absolutely.
And the things I'm particularly interested in is like I broke tapping on the Synaptics driver. It's not listed anywhere in the protocol spec, but it still has to work.
Oh, absolutely. The XTS is clearly only a small piece of the overall what we need to test, but I think it's a piece that's worth keeping, and so I think it's important to figure out how to do it. But I mean, keeping in the sense of making sure we have tests that get coverage. We spent some crazy amount of money back in the day to get XTS. It was a contracted product that we paid a company to come in and write from the protocol specification, and the good news is that meant we got a lot of tests, without much effort on our part. The bad news is that the people who are doing it didn't necessarily really understand.
I think
Unix
XTS
or
suffers
anything
more
else.
from it's been just dumped somewhere and ignored for 10 years.
Well, like I say, it hasn't been ignored for 10 years. We got it out when we were doing the XCB stuff, and it actually was helpful. We discovered some bugs on the client side, that way. And we discovered some bugs on the server side that way, too, actually.
Yeah, I know that. When Dan Nicholson and I auto-tooled it, and I think server 181 was the first one that didn't crash if you run the XTS against it.
Yeah.
So
I mean, I think it's worth thinking about how it fits into what you're proposing to do, even though I think you're right that, we obviously need to test more than just protocol compliance. It would be worth continuing to test protocol compliance. I think we need to figure out how to do it. One thing about Google Test I was curious about, is it something that locks us into some Google frameworks or APIs or anything? I mean, is this just a piece of open source code we get, or is it?
It's essentially, no, you just get the C++ code. It's giant header files. They provide a script. I think Mesa did that. Mesa just imported the sources from Google Test straight into the repository, so it doesn't have to screw around with the build process. XORG-GTest did not do that, which is why the make files are a giant pain. But I think at least for this, I think what we should do is just import GTest as it is. Even if Google later on decides to change it, at least we have some snapshot.
Yeah.
But the risk you're always running is that, if discontinued, we don't have anyone working on it. So you might commit to, as soon as you commit any time to it, you might lose that, but you got that within your library.
That's true with anything. There's no special Google thing that's going to get us in trouble here. Yeah. Cool.
But it certainly has, as far as I can tell, there's no connection with Google Plus or Gmail or anything. It's just a library that can't be used as a library.
Who's first? Oh, okay.
Yeah. Do you think we might need some infrastructure into the drivers? Like, I think what you're doing is mostly black box tests, so you have events you can feed into the driver, and what you can get is the events it actually produces. But maybe you want to check on like a state change in the driver?
I don't think that's the right framework for that. Google Test is essentially built for it. XORG-GTest itself isn't. XORG-GTest is explicitly black box testing. And that's, I think, what we need the most at the moment.
Yeah.
We've got, for the X server, we've got a test directory with a couple of small tests that check for things like, if we run that function with those values, do they actually return the right thing? Which has its own problems.
Mm-hmm.
But I think this one, at the moment at least, is better for black box testing.
Okay.
If anything for state changes, it would have to be integrated into the various drivers.
Yeah.
And one of the reasons I ended up with one set of tests instead of having them sprinkled across the drivers is because building Google Test and XORG-GTest is just such a pain. It was easy to just have one repository.
True. Okay.
We could also switch to CMake, which apparently makes it easier.
I was wondering if you had looked at what Christian did in Wayland for his testing infrastructure.
No, sorry.
So we've been using Google Test in Mesa, and I'm not a fan. The best thing I think the Google Test adds is that when you want to write a test in an existing test file to add a new subtest, you just have a function with a little macro around its name, and then magic happens for integrating that into the list of tests. That was the most interesting part of GTest to me, to not have to have a bunch of extra infrastructure in your test file. What Christian ended up doing was his little macro puts the function into a structure that goes into an ELF section, which then the main test runner walks through the ELF section and runs all the tests in there. It looked like a pretty cute trick, and it means that the framework is like 200 lines of code instead of, oh my god, all the G-test code. So it might be something to look into for Xorg if you're ever dissatisfied with Google Test.
Yeah, definitely. Thanks. I wasn't aware of that. So I had a quick look at the Mesa stuff. One of the main reasons I started with this is because Chase tried to get some integration testing into the server 113, which we didn't end up merging. And I figured, well, it's already there. I had a deadline at work that I needed to meet to get all these tests done. So I figured I'll just take that as it is and play with it. Google Tests is a lot more powerful than just providing macro stuff. And that is what I've come to slowly start to appreciate. Initially, the only thing I saw was the painful build. But as I said, running things like that, I don't know if you can read that down there, but you can provide a G-test filter, so now it runs every scroll test. You can see how it's scrolling in the background there. And it only runs the scroll test. You can randomize tests. Google Test will give you the seed for the random. So what you can do is you can run the same tests in different orders, and if anyone blows up, you can actually reproduce it in exactly that order and figure out why the state left after the tests. All these little things that you don't really know of until quite well into writing tests are the ones that you'd have to re-implement in whatever test suite you write. So that's why I definitely don't want to write my own test suite. If what Wayland does has these features, it'd be awesome. Yeah, as anyone who's ever tried to write a test suite, it's boring. It's incredibly boring to write the test framework. It's boring enough to write the tests. So. And in terms of the importing, I think Google Test provides a Python script that merges all the files into one. So you really have only one C file to link, or to compile and link against if that becomes too much of an issue. But compilation is a technical problem. That is a time problem. Writing a test framework is a time problem. So, can anyone see that being useful for output tests as well? I don't want to be the only one writing tests. Egbert?
I think we have something like render check for the DDX drivers, and yeah, it seems like it doesn't get touched in the last time, so I've tried to run it to check some things, and all the gradient tests broke because the test is now actually wrong because the software rendering was changed in the server, and nobody noticed or worried about this. So yeah, it certainly would be nice to have all those tests also in a consolidated framework where we just can run all those tests together with other tests for the X server.
That is the integration bit that I mentioned before, where I can't remember if you're probably not going to find that command, but gtest somehow has a command that it spits out XML and you can pump that into other systems. So similar to the Tinderbox, Jeremy already complains whenever we break the Tinderbox. So we've fixed up the not building X server. We're pretty quick in fixing that up these days. Similar thing can be possible here.
Yeah, that would be really nice.
So in the realm of probably crazy ideas, so don't everybody jump up and start screaming, it occurs to me that what we did with XTS, which is to actually get together some money and pay somebody to write a whole bunch of tests real fast, is something that it's not impossible we could do again. I'm not sure it's a great idea for several reasons. You know, it's not clear that, unlike with the protocol, it's not clear we have a spec here, right? So somebody would have to at least figure out what tests needed to be written, which is hard.
I think that is probably the main issue here. It would be much simpler to simply have a requirement that if you fix this in this bug, you need a test case for it.
Well, so there's regression tests, and then there's, you know, functional tests, right? And, you know, I think regression tests are great, and we absolutely need to do those. But the thing that XTS did, and that a real functional test suite will do, right, is to actually catch bugs before the users experience them. That's an awfully good thing. I would like to see, no matter how we do it, I'd like to see at least some proactive functional testing where we sit down and figure out what's supposed to happen and do it. I guess all I'm saying is that as a board, one of our jobs in the foundation is, to provide financial support and logistical support for those kinds of activities. If the community came to us and said, we really need help with this, we would certainly listen. And I just wanted to point that out. If you can think of ways we could usefully spend time, money, or energy working on the testing problem for X, I think, yeah.
Okay, cool, thanks.
I'd just add one thing to that, Bart. If you're going to do something like that again, avoid the dump problem. Pay one of you to do it.
Yeah. We got similar issues with the whole dumping problem of like, you write something, you move on, because there's an expressing thing. So it's not going to be it's lying somewhere untouched for 10 years, no one knows it. But I think the bit rot problem is much more one of it doesn't get executed, and less one of it's just been dumped somewhere.
Yeah, there's some things we did wrong and things we did right with XTS. And one of the things we definitely did wrong was end up with a test suite that wasn't really, that the community had no engagement in maintaining. That's absolutely right. But one of the things we did right, in my opinion, is that the project was put through a formal RFP process so that it was really clear that it wasn't just the foundation funneling money, well, not at the foundation, the consortium at the time, funneling money to their friends to do work. We've tried that plan at various times in X's history too. So I think this is the key reason why we would need to have a much, much better specification than we have now, is that, it would be nice to take that specification if you were going to go that route and put it up for a full-on formal RFP process with a competitive bids and evaluation process and the whole thing. It would be a big deal. I'm not claiming this is the right way to go. I'm just pointing out that, the foundation has been charged with sort of trying to provide support, and testing is one of these areas where, in general, proprietary and closed source world has done better, partly because they've been just willing to throw resources at trying to do this. It's hard for us to do it in the open source community sometimes, and so, any way you can figure out that we can help as the foundation to, sort of get the product in a better testing space, don't hesitate to ask us. Totally.
Thanks. So just the last question, does anyone see any showstoppers in there? Because otherwise I'll just keep plodding along until I have something useful, or more useful anyway. But, if you see any, if there's any bells ringing, alarm bells ringing, please let me know now. All right, thank you.
Yeah, thanks, Peter.